מודל קלאסי.
זה ולקחת קצת פעם, לא?
אצלם הקורס אחד, שנה הבאה.
כדאי שיעבירו את זה לאנגלית. כדאי שיעבירו את זה לאנגלית. Okay. So, I guess we're doing this in English. Is that right?
You were this?
For amplification now or for recording?
For the recording.
So, okay, so I guess if you're here, you're not at the workshop. So if you want, we can try to end by 11:30. So you can go to Donnie's talk if you want that. But there's no break then. Okay? No? Well, you can't have both. We can have a short break, like 5 minutes, and then have that. And tomorrow I'll be teaching as well. So tomorrow is usually the PA class, but we switched classes, so I'll be doing today and tomorrow, and he'll be doing next week. Okay? Okay, so some administrative stuff. So this is course 76915, Introduction to Information Processing and Learning. And it has a nice ring in Hebrew. Ibud Meida Vel Mida, it's like a small poem. And I'm Amir Gloverson, and I work in machine learning and some neurocomputation as well, and language processing. And your TA will be Roy Livni, who's a grad student working with me. And he knows learning very well, so I'm sure he'll do a good job. There'll be 2 hours of my class and 2 hours with Roy's, and there'll be weekly exercises, more or less, bi-weekly, mostly theoretical, but with some programming stuff to show you how things work. And I think we'll write the administrative stuff like with respect to grades, but the final grade, I think it's 25%. I'm not, don't quote me on that, so we'll have the number on in the website, but it'll be something like 20-25% the grades out of the final grade of the course, so the exercise grades, and it won't be all the grades, so it's probably some fraction of the exercise, so you don't have to do say 1 or 2 exercises, but the number will be posted. Okay, but the idea is that you should do the exercises. They're very helpful for understanding the material, and so please do that. Okay, what else? In terms of administration, I think that's it. So how, just to understand who's here, how many of you are ICNC L6 program students? Okay, so it's the majority more or less. Computer science? Undergrads or? Graduates? Yeah. Other? You are? What field are you?
I'm guest student for this year.
You?
Master in neurobiology.
Neurobiology? Okay. Alright, so I mean, sort of this is the reality of this course is that it's usually a heterogeneous group of students with diverse mathematical backgrounds. So anything that you feel is sort of strange or you're not familiar with, just please ask me or Roy, and we'll try to bridge the gap or explain things. Sorry? Yeah. Okay, so please ask us, okay? Because we might since we don't know what everyone knows, and we might assume that you know something that you don't know, and we don't want that. Okay, so I say the overall theme of this course is to give you basic tools, mathematical tools, formal tools, conceptual tools for thinking about learning and information processing. And of course, we're interested in these things for multiple reasons. One is that we'd like to understand how we work, or how animals generally do the great things that they do. Like, what do we do that's impressive to you?
We remember.
Sorry?
We remember.
We remember. Okay, so that means we represent things, right? We have some abstract representation for things, but we remember. So memory is certainly impressive. Although a hard disk remembers as well, right? So it's not just recording. We learn, right? We somehow learn from our experiences. If we failed in the past, we often not fail again. Yep.
We can decide.
Right. We take decisions. And I think, I've been trying to think what's the most succinct, description of what we do, and I'd say we manage to get things done. It's when, we set goals for ourselves, to stay alive, to nourish ourselves, to get to places, to I'd say achieve goals generally, right? We don't necessarily think of it that way, but we manage to avoid things we don't want, and we manage to accomplish things that we want, right? Whether it's getting to work in the morning, getting through academic studies, getting food on the table, etc. Right? And I'd say mostly primarily staying alive, and then all the other things we might want to do with life. Right? So okay, so I think that's something we achieve. And why is that impressive? Let's think of a fly, even, or other maybe less developed animals in terms of cognitive skills. So why is it impressive that it manages to keep itself alive? What does it need to do?
Complex, rapidly changing environment.
Yeah, so that would be the bottom line of what I was thinking. It doesn't really have full information, or very even partial information about the environment, right? It doesn't know where the food is. It doesn't necessarily know how to get there. It doesn't know what the dangers out there are. Even if it sees food or potential food, it doesn't know if it's poisonous or not, right? So it has very little information about the environment that it lives in. And I think, if we want to be humble and realistic, it's true for us as well, right? We know very little about the world. I look at you, I don't, I can only guess what you're thinking, but it's in your private mind, right? So even when we conduct a conversation, what I know about what you're thinking is only through the medium of speech, and so that's very partial information. So generally, I would say we live in a very noisy, information-restricted environment. We know very little about what's out there. We could also, the way we can affect the environment is also fairly limited, but we somehow manage to make do with that. Okay. So another, I'll say, field that's also true and our impressive accomplishment is science. Right. We, in the process of history, have managed to figure out some things about the world, right, that were not explicitly written to us or given to us in any form. Right, we had to figure out these things about the world, which we didn't know in advance. By what did we do to figure this out? So forms of observation and let's say induction or theory construction, right? So we observe things, and then we construct theories about the world, and then we test them. Okay, that's how science progresses. But if you think about it, science is also this creature living in a world that it knows very little about, and trying to figure out what what it can say about this world and how it can use it or manipulate it or use it to its advantage and thrive. Okay, and it's pretty impressive that we managed to make some progress with this. It could have been much worse. We could have stayed in the case, tried to figure out mechanics and all these things, and there would be some really complex laws that we never would have figured out. Right? And there are some things that we still haven't figured out, right? Like brain, for example. So it might be that we have to be humble and to accept the fact that there are potentially things in nature that are beyond our comprehension. But the miracle is that we've managed to explain the great deal of natural phenomena. Okay, so what I'm trying to suggest is that part of what is impressive in what we do, and also in the scientific endeavor, and what in animal behavior, is that we manage to behave in a world that we know very little about. We manage to perform actions in this world, and these actions have desirable consequences, even though our knowledge is partial. Right? Okay. One of the goals of this course is to formulate this problem. Okay? Formulate what it means that there is an unknown world. How can we have an abstract theory of that? Formulate what it means to perform an action, and what the cost of this action is, and most of all, that's the most important thing, formulate what it means to be optimal, or to behave in a desirable way. Okay? So what's a good strategy? How do we quantify a good strategy? And given a particular model, how do we calculate? How do we find a good strategy? Okay? Just stop me if you have questions. Okay. And as I said, I think these things are basic sort of abstraction tools that you will need in thinking about both, many things. Science in general, cognition, animal behavior, cognitive psychology, many other fields like economics. I mean, almost in any field where you have to think about uncertainty in decision or behavior uncertainty, these are the tools that you need to have at your disposal. And certainly understanding the brain and neural computation, this is a basic thing, because we want to understand how the brain performs these calculations or exercises this behavior in a noisy environment. And lastly, there's a field where we want to understand these things, such as learning and behavior, because we want to build machines that behave in this manner. So machines that learn, that can act under uncertainty, that can mimic intelligent behavior, that can understand complex things like text and language. Text and language is the same thing. Images. And there's been huge progress in this field over the last, say, 20 or more years, and you all see this every day when you search for text on the web. There's a feeling that you're talking to, when you're searching and you're asking a question or a query, you get an answer that somehow fits, but roughly, at least much better than 20 years ago fits what you had in mind. So there is a feeling that you're conversing with an intelligent machine or algorithm, right? And this is going to get much better over the years. For example, machine translation is now much better than it used to be. I don't know if you played with translation engines. They're still, pathetic compared to humans, but it's much better. So once you understand, the opposite way, if you want to build machines that learn or do, intelligent things, you have to understand the mathematical theory, or how to abstract what learning is, and what is optimal learning, etc. Okay? And this is most of the tools that are used to build these image recognition software, text translation, etc., are built on these basic principles. So you won't be able to design a machine translation system when this course is done, but you'll have the basic tools for understanding the concept of how these things work. Okay. All right. So in terms of textbooks, it's pretty Not as eclectic as a good or bad word, but it's pretty spread out course in terms of the material that it covers. So there are various books that that would be useful for you to look at. And nowadays there are also hopefully online courses. So Coursera has a nice course by Andrew Ng, co-founder of Coursera. Sorry? Yeah. Andrew Ng. I don't know how to pronounce his name. So, yeah, he has a couple of online courses, I think, some on Coursera. But I think, if you go for online courses, just shop around and there's a variety of options, and you can come to me to ask if you can't find anything suitable. But I would still highly recommend looking at paper textbooks that cover material in a principled manner, and there are a bunch of those, and I'll mention the relevant ones as we go along. Okay, so I'll just give a very brief outline of what we'll discuss in class in the course of the semester, and so I'll also give you an idea of what we'll have. I've never written English on a board, so it can't be much worse than my Hebrew. But let me know if you can't read stuff. Okay, so. So a very high-level outline of what we'll discuss is we'll start out with, as I said, one of the things that I think I'm most impressive about cognitive behavior is making decisions under uncertainty in a noisy environment. So we'll talk about statistical decision theory, which is a pretty basic, but I think also revealing theory of how it's one way of thinking about making decisions in a noisy environment. So we'll set up the problem. We'll say what's the optimal way to behave in an environment. So supposedly you'll have the perfect tool for life after this, if you can write a self-help book. And okay, so that's the first thing. Then we'll talk a bit about hypothesis testing. Who has heard about hypothesis testing? So anyone who's done any basic sort of statistics or scientific work should have heard about these things, because when you want to prove to the world that you discovered something, this is at least in the classical scientific community, this is how you do things. Okay, so hypothesis testing is the thought process and a specific mechanism for convincing yourself that you have found something new about the world. Okay? Let's say you develop a new drug, you want to prove that the drug works. This is you want to say, I think the brain has two independent hemispheres. Okay. So you need some mechanism for thinking about scientific discovery, and this is the dominating one in the scientific market today. Let me talk into arguments, but we're going to talk about it. Then we'll switch to parameter estimation. So, or even more generally, density estimation. Which is generally the problem of understanding, of quantifying uncertainty in the world. So let's say you have, someone gives you a coin, you want to understand is this a fair coin or not, okay? How do you do that? How do you figure out, is things, or a cube, to understand what's the probability that the cube will land on 2, okay? Or you have you measure height in a population, you understand how these heights are distributed, okay? So basically, you want to characterize distribution. So you want to characterize the uncertainty via simple models. Okay, so this is generally the problem of density estimation or probability estimation or parameter estimation, and we'll talk about that a lot. We'll mention the EM algorithm, which is a very useful algorithm in this context. Then we'll switch gears a bit to talk about the problem of classification, which is the most fundamental problem in learning. So classification is the problem of you see an object. Let's say I write this on the board. I ask you what's that? What is it? This is 6, right? What's this? 4. Right. Okay, etc. Okay, so classification is a problem where you give, you have some object as input, and the output should be the class of this object. Okay, so binary classification is when you have only 2 classes. So say you want to say, well, this is a 6 or a 4, this is a 4 or a 6, but there are many other variables. Okay. So I'd say the most advanced form, or one of the more challenging forms of classification, is you see a visual scene, and you have to, for each pixel in the scene, you have to say what object is in that pixel. Okay? So there is Itamar, it is a purple shirt, and okay? That's the door. Okay, so this is, I'd say, the holy grail of machine vision nowadays, is to do this sort of classification. To take an image and to say for each pixel in the image what it is.
To do it for more than one picture.
For all pixels in the image.
You can say this pixel is
No, this pixel belongs to Itamar. Yes, Itamar is a collection. There will be multiple pixels that are Itamar pixels. Okay, and they could have also they could be both Itamar and Itamar's beard. Okay.
Just like Facebook does with recognizing the
faces. Yeah. So face recognition is also an important and a challenging classification problem. Okay. Sorry? Yeah, obviously. I mean, there are no perfect. We don't do it perfectly. Okay. The problem is it's not. Okay, the problem is hard, okay, and we can fail, obviously, in recognizing faces, and if someone wears a silicon mask pretending to be someone else, then what is the correct answer? Right, so it's a hard problem, and but machines are actually pretty good at it nowadays. Face, like the engine that Facebook uses and others, it has pretty high accuracy, but obviously it fails. Okay. Especially, the question is out of how many names do you have to recognize? Okay, so if I have to recognize you guys, how many are you? 30. Okay, I can probably handle that. But if I now have to memorize 100,000 faces, I heard that politicians, this is like the number one thing that you need. You have to say hi to random people and make them think you care personally about it. Okay, so classification is a key problem in machine learning, still obviously not solved. And so we'll talk about classification. And we'll use classification to think about, or to talk about the mathematics of the most fundamental theoretical problem in learning, which is learning and generalization. Okay, so let's say I tell you this is a 6. So I'm now teaching you my handwriting. Okay, I say, okay, let's do a different game. I say, okay, I didn't learn like standard Roman digits. I have my own system which you have to adapt to. Okay, so this is my 6, and this is my 4, okay? Right? And now I ask you, okay, what is this? Okay, so, right, but you're not sure, right? If I can tell you, you think this is a 6? No, this is not a 6, it's actually a 4. Why is it a 4? Because a 4 is anything that has pixels above this line, okay? Now you failed miserably, right? And okay, and we can keep playing, right? So what is the problem here? That you saw a particular small, very small sample in this case, and you had to learn from that, and you had to generalize to new cases, right? But it's not. It's actually hard to even define what it means to generalize to new cases, let alone build something that successfully generalizes. Okay, so we'll talk a lot about that, about the theory of learning and generalization. And there's been a lot of beautiful mathematical theory, starting in the maybe 70s, and one of the most impressive achievements of this theory is something called the VC theory, which is Vapnik-Chervonenkis. There's also Pack theory, which is related to VC, and this was developed in the Soviet Union. This was in the States, and some interesting history there. Okay, and then you might be thinking how we can squeeze all this. That is cause for concern. And then we'll end with a field called information theory. Which is a very nice, clean mathematical theory of data representation. So what does it mean to represent data compactly, to compress data? What does it mean to transmit data from one place to the other without errors? Say noisy channels, for example, when I talk to you and I try to convey messages using a noisy channel in the sense, a noisy system, let's say, in the sense that my vocal chords are noisy, and there's a noisy medium between us, and there's a lot of uncertainty. I don't know exactly what you understand from what I say. I don't know what your language training is, etc. So how do we design a language that lets me communicate things to you? Okay, so it's sort of a miracle, right? That people have managed over the span of our existence on Earth to generate a language that lets us communicate such elaborate meaning. Okay, animals can't do it. Right? And I was thinking about this today, that if you have, for example, babies can't talk, and one of the, I think you'll get maybe not a Nobel Prize, but you'll earn a lot of money if you manage to build a machine that translates what babies want. Right? You look at a baby crying, you don't know why he's crying. Is it tummy aches, sleeplessness, hunger, etc. Because there's no language, right? There is some minimal. There is a communication mechanism, but there's no language. So, and once we have language, we can communicate these things easily. Okay, so it's a pretty amazing tool, and it's pretty amazing how it evolved to where it is now. Okay, so it has to satisfy something. Language has to satisfy some properties for us to communicate using those assessments. Okay, so information theory talks about that. What does the language need to satisfy? What's an optimal language in a certain sense? Okay. Okay, and that would be good. Okay, so we'll try to make these things formal, because I think it's important to understand the mathematical structure of these things, also in order for you to be able to analyze new problems. So we'll obviously do some math, and as I said, I understand that the background is diverse, so please stop us if you feel that things are not going the way they should. Okay, so yeah.
A question about books. There's a little white book in Hebrew called Mavot B'Lev Midah,
Right.
which is available here and in other places. Is it somehow relevant?
Yeah, it's very relevant. I mean, it was a textbook of this an earlier version of this course, which still considerably overlaps with the current version. It's a bit outdated in certain aspects. I mean, in the sense that we cover more material now, more different material. But certainly, it would be helpful for you to use, and I think you can get it for free from Muti or ask Muti. So there is a textbook in Hebrew from Muti, Naskuti Suchi, it's down there. But it's also available online, I think, at Gal Chechik's website, at least it used to be there. So Gal and Tari Tishby and Lido Stroyansky wrote this book. So just Google Gal, and I think it shows up as, under books in the publication list. So it's useful, I think, and it's in Hebrew, which might be an advantage to some. There's also the online course notes that I will publish. We haven't picked a website for the course yet, so we're debating using Moodle or not. Are you all? It's nodding. What? It was okay? But Moodle is good. I think we will use Moodle only if we are sure that anyone can just enter it freely. Okay, so there are no password issues. Like we wouldn't use the CS Moodle, I think, because we need the CS passwords. That won't be good. So we'll choose something that is accessible to all.
You can open it to the access.
Yeah.
Because you can choose the Moodle to kind of access one.
I know, I tried accessing today without a username and password and it wouldn't let me, so I want to make sure that it's... is this also for non-students?
Yes, you can open it to
the world. Okay. So we'll try that. It has some advantages in terms of maintaining things, so we'll see it in the story. But wherever that website is, we'll post the course notes, the lecture notes I'm using. But I really encourage you to look at other sources as well. So don't misuse the fact that there are 100. Okay, other question? Right. So we'll start with talking about statistical theory. What I'll talk about more specifically is something called Bayesian decision theory. So I'll try to highlight, that the fact that there's no one single correct way to go about it. Okay, so I'll try to highlight where specific design choices for the theory are made. So our goal now is to think about the problem of making decisions under uncertainty and formulating it as a mathematical problem and understanding what defining some notions of optimality in decision making and seeing how this works. Okay, so let's take a simple example. It sort of crystallized over I always use it. I don't like it anymore, but somehow forced to use it. So say you wake up in the morning. This course always happens around the autumn, and you're not sure how to. You're not sure if it will rain or not. Not sure what the weather is. It's autumn. It could go either way. So you don't know how to prepare yourself for what's out there. Okay. So what choices did I have in mind? So you could decide between taking an umbrella, taking a coat, and staying at home. Okay, so that's also an option, right? If you think it's going to be terrible outside, then might as well stay at home. Okay, so these are the things that you might consider doing, and okay, so why would you consider doing one or the other? Okay, so I mean, you're thinking about outcomes, right? You're thinking once I step outside with my umbrella, coat, or whatever, there will be a weather out there, right? I don't know what it is, but if I wear a coat and it rains, then I'm moderately happy that I did the right thing. Yes. Right, exactly. So cost is what I'm paying against. So if I wear a coat and it's very warm, then it's unpleasant, right? And I had to, and in some very concrete sense, I'm paying a price for it, right? So I pay, well, let's say there is a price to pay, okay? And it would be high if I wear a coat and it's warm, right? On the other hand, if I don't take an umbrella or wear a coat and it's raining and cold, then I'm also paying the price, right? You can maybe quantify this in dollars, right? Say I'm ill, now I have to go to the doctor, I'm losing a day of work, and I might get fired, etc. And so, yeah.
Basically, since you have to take into account the probabilities as well,
right.
So what you're doing is calculating the expectancy.
Right, so you're 2 steps ahead, and you're trying to formulate a probabilistic or mathematical theory of what's going on, and things that you can calculate in order to behave optimally, right? So it'll end up more or less like what you're saying, but we want to understand better this strategy that you're proposing. Why is it good, okay? It seems plausible that you should think about uncertainty, okay, and somehow quantify it to your advantage, okay? So what does that mean? Okay, so there are possible actions. There is the things that will actually happen in the world, right, which is the weather, and there is the cost or the price we pay for taking particular action in a particular world state. Okay, and if you want, okay, we'll talk about this a lot later on. But if you want, this cost function is subjective, the most subjective part of this theory, right? Because some people might like singing in the rain without umbrellas, or and some might find it terrible, right? So this is, I can't build a theory for all of you, because you have to give me the least count, right? Okay. But these are certainly things that we have to bear in mind. And the last thing which people have alluded to here is uncertainty. How do we quantify uncertainty? Okay. Because one day if I take an umbrella and step outside, it might rain, and the other it might not. Okay. So there's some uncertainty. Things change, and these are the things beyond my control that behave in some say noisy or probabilistic manner. Okay, I cannot fully predict the outcome.
Actually, I think our predicting is very bad, and human predicting is very bad.
Well, because okay,
It's not we actually do the statistics. What was it last year?
So okay, that's obviously an open, well-studied problem, but not yet fully understood. People receive Nobel Prizes for this, right? For understanding exactly how people handle uncertainty. Is it optimal in a sense? How do we calculate probabilities? So Kahneman and Tversky, obviously, and there's a whole field of behavioral economics which looks at these things. A nice book by Amos Danarian. And others. So exactly how we behave with respect to what is, say, optimal. Okay, so I'm first going to convince you that optimality is there's no one notion about statistical optimality. Okay, and once we understand how to think about that, we can also understand what people do and in what sense is that sort of guidance. Okay. All right. So I missed just one thing in this story that I told you, and that is that you know, when I wake up in the morning, I do get to observe some things about the world, right? I can open the window and see if there are clouds out there. I can, what else can I do? Yeah, I can look at the weather information on the web. I can just write the weather in Jerusalem and I'll get the forecast, etc. Right? And I can, for example, remember what happened yesterday or last year around this time of year. So there's a lot of potential observations or information that I can look at in order to improve my decision. Right? Okay. So these are basically the components. Yeah. So let me draw a sketch a diagram that we keep coming back to. So this is say unknown. No. If I have embarrassing typos, please correct me. So there's an unknown world state, or call it unknown world. So which this box encapsulates everything that's about the world, including maybe things we know, but mostly things we don't know. Okay. Okay. So for example, let's say you're a pigeon and you want to eat a seed. You don't know for sure if it's poisonous or not, right? That's a very interesting experiment on how birds learn to avoid certain foods. So a lot of things are unknown. We would have liked to know all of them, but tough. We can't. And then we get to, we are lucky enough to observe something about the world. So there's an observation. Yeah, I see it's going to be bad. Is the size, font size okay? People in the back? No? A bit larger? Or it won't help? Okay. Well, I approve. Okay. So there's observation, which is what we get to see about the world, right? And so, if we're talking about face recognition, so now I have had one glimpse of you guys, or multiple glimpses throughout 9 minutes or so, and these are my observations, at this point. And next time when I see you, I won't necessarily. Well, I still don't know your names actually, so I could ask Itamar what his name is, and I observe him for 90 minutes. Okay, so these are my observations. And then next week someone comes in, okay? I don't know who he is necessarily, so it's unknown to me, okay? And I want to say, okay, your name is Itamar, okay? So what I'm trying to say is that when we learn rules, okay, and we learn to classify things, we observe instantiations of these rules. So we observe like we have here. So these would be the observations, okay? So a lot of interesting things about interesting learning processes you can have in this way. And then once you observe whatever you observe, you take an action. Okay? Now, so how should we think about whether this action is good or not? We hinted before that there is some cost linking the action and the true world state. Okay? For example, if I did not wear a coat or take an umbrella, that was my action. I step outside into the unknown world, okay, and I suffer the consequences of the unknown world. Right? I didn't know it before, but now my action has a cost with respect to that. Okay? Alright? So for example here, if I ask you, what is this thing? And you say it's a 4 or a 6, you don't know the answer, right? The answer is in my head. There is an answer out there. Okay? The unknown world doesn't mean it doesn't exist. It means it certainly exists, but you don't know. Okay? So the answer whether this is a 4 or a 6 exists in my head. Let's say I wrote it on a note and have to commit to what I wrote there, but you don't know it, right? So your action is, what would be your action then?
Guessing.
Sorry?
Guessing.
Yeah, but saying something, right? You're not really guessing because you have this information, so you're not working in a no information regime, but you're saying something. You're saying your 4 is 6. So you perform one of 2 actions, right? And what's the cost? Well, that's subjective, right? You might not really care if you get it wrong. I know there might be a course where if you get the first question wrong, you're going to fail, right? So that's highly context dependent, okay? Situation dependent. So there's an action, and there's let's say intuitively the action is meant to work well in the world that you don't know, right? But the precise cost that you pay is something that math cannot tell you. It's something that you have to decide. We can do a 5-minute break. So we convene at 10 to. Okay. לא עובד? אני חושב שהוא לאו דווקא אמור להישמע, אני הולך אבל אני לא יודע. יכול שהוא ידעתי.